Hello. Today we are going to be learning, let me get this back. We're going to be learning about the line of best fit in a scatter plot. Okay? At the end of the lesson, you will be able to write an equation in slope-intercept form for the line of best fit. Hopefully you remember slope-intercept form, always y equals mx plus b. M is your slope. B is your y-intercept. Okay, and then you will also learn how to use your equation to make predictions or conjectures, okay? So the line of best fit, when data is collected, the points graphed usually do not form a straight line, but they may approximate a linear relationship. It means it kind of looks like a line, or it could be a line. A line of best fit is a line that is very close to most of the data points. This is the line that you can sort of see when you look at a scatter plot. Okay, let's do some examples. Refer to the information in the table about the cost of cookies. Construct a scatter plot using the data. Then draw and assess a line that seems to represent the data. So they've drawn the line, or they've put the points in from the table. So like the ordered pairs would look like 0, 2.59, 3, 2.67, etc. Those are your ordered pairs. This is your X right here, and this is your Y, okay? Graph each of the points and draw a line that fits the data. So they've basically drawn their line like kind of right through the middle of most of the data points. About half of the points are above the line and half are below the line. Judge the closeness of the data points to the line. Most of the points are close to the line. Then if it says use the line of best fit to make a conjecture or guess about the cost of cookies in 2013. So right here. So years since 2000. So we want to go out about 13, so that would be right about here. So you kind of just draw this up to the point, and it looks like that would be like, what do you think? It should be close to about 3.35 maybe? Let's see, so yeah, 3.35 is about right. So that would be about 3.35. Okay, go to your next page, and these are your you try. I want you to try number 1 and number 2, or A and B as it looks like here. You've got a bunch of points on the scatter plot. Draw and assess a line that seems to best represent the data. So you're going to kind of want to go through where you have half your points above the line and half your points below the line. Okay, you may have an outlier. That's okay. Then use the line of best fit to make a guess about the points the driver will score in 2015. So this number right here. I want you to make sure you show your line. Okay, go ahead and go to the next one. All right, now we've got an example here where the scatter plot shows the number of cellular service subscribers in the U.S. Write an equation in slope-intercept form for the line of best fit that is drawn and interpret the slope and y-intercept. So basically what you can do is pick any 2 points, choose any 2 points on the line, and those can be your data points, or they may or may not be data points. So you can basically find, like they have to be on the line though. So like in this case, they're gonna use 3 and 150, okay, which is right here, and then 9 and 275. Okay, those are the points that they chose to use. Okay, then you find the slope, so y1 minus y2 minus y1 over x2 minus x1. Okay, so our y2 is 275 minus 150 over our x2, which is going to be 9 and 3, so 9 minus 3. So we end up with 125 over 6, which gives us a slope of about 20.83. Okay, so if we were to write a equation and then look for the y-intercept, see where it hits the y-intercept, which is going to be right about there, right? So about 80 maybe, 85, okay? So you kind of have to guess that a little bit. So your equation would be y equals 20.83x plus 85. You find the y-intercept just by looking to see where the line crosses the y-axis. Okay? So your line of best fit or your slope intercept form line of best fit is right there. Okay, I want you to try this one. Or use the equation to make a conjecture about the number of cellular subscribers in 2015. So let's look at our data. You can actually go, since the year 2015 is 16 years after 1999, and you know that because that's the title of your graph here, years since 1999. So you would just plug in a 16 into your equation. Y equals 20.83 times 16 years plus 85. That comes out to be 333.28 plus 85. There will be 418.28 million cellular subscribers in 2015. That's what you got to do. Okay, let's try 3 and 4. So the scatter plot shows the graduation rate of high school students, years since 1998. Write an equation in slope-intercept form for the line of best fit and interpret the slope in the y-intercept. That means say what the slope means and what the y-intercept means. Okay, use the equation to make a conjecture about the graduation rate in 2020. And that's the year since 1998. So make sure you pay attention to that. It's very similar to the last question. So you need to get a y equals mx plus b equation, and then you need to answer what the rate will be in 2020. Okay, remember to find your slope, pick any 2 points on the line, okay? They may not be data points, and that's okay. All right, that is all for this lesson. If you have any questions, please make sure to ask. Bye for now.